Welcome to the user interface demonstration video for our course project for CS5525 Data Analytics through Virginia Tech, Fall Semester 2012. Our group was principally tasked with the analysis of spatiotemporal crime trends, clustering analysis, crime hotspots, and individual clustering crime trends over time in the district of Merseyside, UK. This video will serve as an introduction to our user interface tool, which displays our analysis results to users. Analysis results such as crime by district, crime by borough, crime segregated by crime type such as burglary, arson, and antisocial behavior, case studies for unique crime instances such as the London riots, cross-correlations between crime types both spatially and temporally, interesting data trends, and a year span data trend to demonstrate crime trends over time. And finally, the fruits of our clustering analysis for crime hotspots, individual cluster trends, hotspot tracking, anomaly detection, and displaying all of this information to the user in a way that is both intuitive and comprehensive, so that the user can select broad data, view in, zoom to individual clusters, and gain more information both through the clustering results and through social media metadata about any given crime type or location. In navigating our user interface, the user is immediately presented with a navigation toolbar on the left-hand side and an information panel on the right-hand side of the screen. In the left-hand panel, the user can mouse over larger categories such as crime types by borough, crime types by district or area-wise analysis, view individual case studies, view crime type correlations, view interesting trends about the data, and finally engage in clustering analysis to view the results of our semester-long analysis for this crime area. When one of the subcategories is collected, the information panel on the right-hand side changes, hopefully allowing this information to be presented in a way that lets the user browse categories quickly while remaining aware of where they are in the overall data structure. The remainder of this video will demonstrate some of the key features of our video system. When viewing crime types by borough, previous work has sought to classify crime based on arbitrary or postal code classifications for all different crime categories. For instance, clicking on total aggregated crime shows the key hotspots based on borough for all of Liverpool, Merseyside, Birkenhead, and northern central Liverpool. By clicking on any one of these boroughs, information pops up about the postal code and the total crime count assigned. Additionally, pie charts display crime breakdowns based on crime type, such as violent crime, burglary, antisocial behavior, and arson. These breakdowns are also shown on a month-to-month basis, so that the user may infer trends about the crime over time as well as globally as a breakdown distribution. On the lower right-hand corner of the information panel, Twitter feed, as a source of social media contextual information, shows a cross-section of active crime tweets in Merseyside in the UK. This adds additional context to the spatial data shown in the graph in the upper left-hand corner through Google Maps. Finally, a live RSS feed through Google News shows active news stories regarding crime in the UK, also specific to various crime types. By selecting a crime subcategory, such as burglary, correlations with other crime types appears to the user instead of the pie chart breakdown. These correlations allow the user to infer additional information about naturally linked crime types. For example, if burglary is selected, correlation with other crime types demonstrates that shoplifting and antisocial behavior have a strong negative correlation with burglaries, whereas vehicle crime, robbery, and arson show the strongest positive correlations. In addition to viewing crime by boroughs, users can view crime across districts, such as Wirral, Sefton, Liverpool, and Merseyside as a whole. By selecting Wirral, we can see all crime instances for the entire district of Wirral in Merseyside in the UK. Of note, instead of the pie chart breakdown for crime types, this now shows prosecution data, This allows the user to get a feel for how much of the data in that area has been actively prosecuted by the police constabulary. As before, clicking on any borough will show information about the borough through the Google Maps API. Social media data and RSS data remain the same. In addition to the clustering, district, and borough analysis, our user interface incorporates information about case studies of interest. One such case study is the London riots. The effect of the London riots was felt throughout the entirety of the UK in August 2011. Breakdowns of crime or arrests in Merseyside by age group classification, gender, ethnicity, time-based statistics, and breakdowns of crime types all serve to show the changes in crime in Merseyside as a result of the 2011 England riots. Another case study shown in our UI is correlations both over time and spatially between crime types. This correlation matrix demonstrates the correlation between crime types over month-to-month basis. Of note, all of the diagonal elements must be 1 as the autocorrelation matrix is always normalized to 1. As before, burglary and robbery show a strong positive correlation with time. However, over area, burglary, other theft, arson, and shoplifting show stronger negative correlations. This type of correlation analysis lets users infer which types of crime are naturally associated with each other and how, whether spatially or temporally. As a final case study, trend data is also shown to the user, tracking crime across 1-year span. Lines in blue signify crime from 2011 for crime type. Lines in orange signify the same crime over the same time span, but in 2012. It is interesting to note that crime has decreased almost universally across all crime types in the last year. Finally, the results of our clustering analysis throughout the course of this semester are shown to the user in the Clustering Analysis tab. In this tab, users are able to view crime by crime type. The 3 individual crime types that we chose for our study were burglary, antisocial behavior, and total aggregated crime. Within these individual tabs, the user can select a month to view for all the clustering results. Each of these polygons represents one of our clusters, drawn over all of the instances found for that cluster for a particular month. By clicking on the polygon, pertinent information about that region is revealed, such as cluster ID, total shape area, total crime, crime associated with burglary, and crime associated with antisocial behavior. For the crime type indicated, the user can further select to view more information about that cluster on the rightmost panel. For example, viewing information from cluster 20 shows a relatively stable trend for crime assignments over time for total aggregated crime. Additionally, clustering results are shown so that the user can infer stability about the cluster over time based on its spatial covariance structure. This information will allow crime trend prediction, anomaly detection, and police resource allocation based on the results that users are able to attain from our UI. Additionally, cluster hotspot ranking has also been included in the user interface results. This allows the user to view cluster associations for all clusters for all months in a 2D spatiotemporal color-coded grid. This allows global trends, such as global increases, decreases, spikes, or troughs in the overall crime in Merseyside for specific crime types relative to their cluster areas. Paired with this are the point assignment rankings for each crime type. These point assignment rankings demonstrate the areas or clusters which have the most crime of that crime type per unit area. In conclusion, we feel that our user interface performs several novel and useful functions for analyzing crime in Merseyside in the United Kingdom. Our interface displays a wide range of data types to the user at once, while remaining intuitive and easy to use. Our interface demonstrates a cohesive connection between existing study, for example by borough or postal code, and our individual cluster analysis method. Our UI allows the user to view broad trend information, and within those broad trends, select specific instances for additional detailed study. Finally, our interface presents all of this information to the user in a fast, extensible, and aesthetically pleasing way. We hope you've enjoyed our brief video demonstration of our web-based crime analysis tool for tracking spatiotemporal crime trends in Merseyside, UK. For more information on the crime study, the dataset used, and other apps for study, visit http://police.uk/data.